Distance and time graphs are tricky, but you can get used to them. So this is a distance times graph. This is the passing time, and this measures the distance from the starting point. And we know from the question the starting point is a first aid place where they've just had training. And this shows you that 10 minutes after they start moving, P is 1.5 kilometres away. Q, well, Q's gone slightly slower, they're just under a kilometre away. But after whatever that is, 17 minutes or so, Q's arrived at 1.5 kilometres away. So they're going at different speeds. The question is, the course ended at 15:30, they all went home. Alf rode his bicycle and Nicky walked home. So which of these lines represents Alf and which one represents Nicky? So let's go over what this graph shows us again. Some people confuse it with a plan. It is not a map or a plan. It is a graph simply of the distance from this point here, the first aid centre, where they both start at 3:30, and I've just nicked the scale. This point here shows that P has moved up. So over the first 10 minutes, P has moved to there, and it takes another 18 minutes for Q to get the same distance. So who is going the fastest? Well, I'm hoping it's P, because P has covered the same distance a lot quicker. And as you tend to ride a bicycle faster than you walk, it's likely that this is Alf on his bike and this is Nicky. This is a horrible question, but it does show a few interesting things. Imagine that is a journey. So from 4 o'clock we go from 0.5 of a kilometre away, and by 4:30 we are 2.5 kilometres away. And we can look at this triangle. This measures the distance from 0.5 to 2.5, so that's 2 kilometres. And how long has it taken? Well, from 4 to 4:30, half an hour. And if we divide distance by time, this length by this length, we are going to get the answer 4. 2 divided by 0.5. But if we this is also the y displacement and this is the x displacement. So dividing distance by time is also the gradient of this line. So speed is the same as gradient. Distance divided by time is the same as gradient on this map. And it's no coincidence then that the faster moving P has a greater gradient than the slower moving Q. And it makes sense. You're going to complete the same distance faster if the gradient is steeper. And if you go slowly, you can take hours to complete the same distance. So you might take an hour to do 1.5 kilometres, in which case you're going a lot slower. So gradient equals distance divided by time equals speed on a distance times graph. It's not a plan. So there is a second section to this terrible question. And the second question demonstrates a lot of the features of a distance times time graph. So we'll look at it. Harriet, the third person we've forgotten about, she waits 10 minutes at a bus stop just outside the medical centre. So she doesn't move for 10 minutes. So she's still 0 distance from the medical centre. After 5 minutes, she waits 10 minutes. She gets on a bus. After 5 minutes, the bus stops in a traffic jam 0.5 kilometres from the medical centre. Okay. So 5 minutes is half of 10. That's this distance here. And she's only moved 0.5. Okay, so she goes to there. She's 0.5 away after another 5 minutes. And then it hits a traffic jam. So it doesn't move. And it's in a traffic jam for 12 minutes. So that's 5, that's going to be 10, and another 2 is going to be 12. Then the bus travels directly to Harriet's village. Harriet got off the bus at her stop, 1.5, so that's somewhere here, 1.5 from the medical centre. She was on the bus for a total of 20 minutes. So she got on then, 10 minutes, 20 minutes, she got off there. This is a horrible question. Draw her bus journey. Well, we've just drawn the bus journey. Doesn't move, moves 0.5 of a kilometre and gets stuck after 5 minutes, waits 12 minutes, and then shoots along for this period of time, gets off the bus. Harriet got off the bus and then walked 0.5 kilometres to her home, and she walked at a speed of 2k. Pretty slow. How long does it take to walk 2k? How many minutes did Harriet take to walk home from the bus stop? Well, time. Let's see. Speed equals distance over time. Time equals distance divided by speed. Time is equal to 0.5 divided by 2, which is a quarter. So a quarter of an hour. So from 1600 hours to 1615, and she walks the remaining 0.5. Harriet lives further from the medical centre than Alf and Nicky. Well, she's got to get further away than him, and it's such a poorly written question, this. But she's got to get up here, really. You sort of intuitively know it's on a straight line. Terrible question, but it does show that when it's flat, you are at rest, and gradient is a sign of speed. So flat at rest, you ain't moving. You ain't moving waiting for the bus. You ain't moving when the bus is in a traffic jam. And then gradient equals speed. So that is the fast bit on the bus. That is the slow bit walking. So here's a horrible question to cap it all. She left her home at 10 to cycle to the park. On the way she stopped at a friend's house, then continued her journey to the park. Here is a distance time graph to show her journey to the park. So we've got time along the bottom, distance from home, vroom, stops. Vroom. What did I say? On her journey to the park, did Jelena cycle a faster speed before or after she stopped at her friend's house? Well, that's the journey to her friend's house. That's the journey after it. I'm looking at it, and I think this is a steeper gradient. So I think she cycled faster before she got to her friend's house, and I'll give you the reason. The gradient is steeper. I'm not going to do any calculations. She's done 15 kilometres in an hour. I could say it's 15 kilometres, and I could work this one out as well, distance divided by time, but I don't need to. The gradient is steeper. How long did Jelena spend at her friend's house? Well, when it's flat, you're at rest. She's at her friend's house for this period of time. How long is that? Well, 11 to 12 is 1, 2, 3 of these boxes, little boxes, and this is one box she rested for, so it's a quarter of an hour. Jelena sat on a park bench for 45 minutes, then took her 1 hour and 30 minutes to cycle home. Draw the remainder of her journey on the graph. Right, so well, this is terrible because I put this over here, but we need to go 3 of these squares along because she is flat and at rest. And then that is quarter to 1, quarter to, it's 12:45. Add an hour, 1:45, add half an hour, 2:15. So she's going to be back to cycle home. When you cycle home, you're naught distance from home. That's an important point. When you come back to this line, you're back at home. So I draw a line from here to that point here. This is a higher maths question. They do a lot of these. But again, it shows flat at rest, and the steeper you're going, the faster. I hope that helps. Best of luck.